The next thing we're going to go over is simplifying radicals. Now, just like fractions, all radicals have to be simplified. And we're going to go over a procedure that's going to tell us what these radicals look like once they're simplified and how to simplify these radicals. And what's important is the index. In previous videos, I've gone over what the index is. It's that number on the radical symbol. If you don't see a number, it has an index of 2. Now, that index number is going to tell you how many of a kind you're looking for. So what we're going to do is we're going to break down these numbers up under the radical symbol into prime numbers. And if the index is a 2, you're going to look for pairs. For every pair, you can set one on the outside. Same if it has a index of 3. If it has an index of 3, we're looking for 3 of a kind. It has an index of 4, 4 of a kind. On all these examples right here, we're only going to worry about an index of 2. Our first example is this, the square root of 16. Hopefully everybody knows what the square root of 16 is. The square root of 16 is 4. If you know the square root of the number, then you simply write that answer down, is 4. And this doesn't require any more simplifying. So if you know the square root of something, you simply write that number down. Remember, this is one of 2 numbers that are exactly the same, that when you multiply it together, you get 16. It's almost like you've got a pair of them. It's 4 times 4. You're pairing those up and you're writing one of them down. So, then we get to one that looks like this, the square root of 18. The square root of 18, like if I had a calculator and I tried to figure out what the square root of 18 is, it wouldn't tell me. I take a calculator and I go, okay, 18, hit the square root, it gives me a decimal. So what we're going to do is we're going to go through a procedure that's going to show us how to simplify this. And we're going to call this upside down division. And what we're going to do is we're going to take this number that's up under the radical symbol and we're going to make an upside down division bar. And we're going to divide this by prime numbers. Examples of prime numbers, 2, 3, 5, 7, 11, 13, so forth and so on. I always pick the smallest prime number that will go into this number up under this upside down division bar. So I'm always going to start with 2 and I'm going to use 2 over and over and over again until I can't use 2 anymore. Then I'm going to try 3 and then I'm going to try 5. Once I get a prime number, then I'm going to stop. So I'm going to try 2. Will 2 go into 18? Yes, it will. 18 divided by 2 is 9. If this right here is not a prime number, then I make another upside down division bar. 9 is not a prime number. I see if 2 will go into 9. Will 2 go into 9? No. Will 3 go into 9? Yes. 3 will go into 9 3 times. Once I get a prime number, 3 is a prime number, then I stop. These numbers up under the radical symbol aren't important. What I've done is I've broken this number down into the prime numbers that make it up. And since this index right here is a 2, the name of this game is finding pairs. Because up here, it was almost like 4 times 4 is 16. I took a pair of those and I only wrote down that 1 4 as my answer. I'm looking for pairs here. There's a pair of numbers that are the same that make up 18. That would be these 2 right here. So what I'm going to do is I'm going to make this radical symbol, and for every pair I can write that number on the outside. See how I have a pair of 3's? That means I can write a 3 on the outside. For everything I have a single of, it goes on the inside. So a pair allows me to write one of those numbers on the outside, and anything I have a single of is left over on the inside. The square root of 18 simplifies into 3 square root of 2. When you can't find the square root of a number, if it doesn't come out immediately to be a whole number, that is simplifying it, then you need to go through this process. I can't take the square root of 18 and get a whole number, but I do have a pair of 3's in there. That allows me to write 1 3 on the outside, and I have this square root of 2 left over. Our next example, the square root of 50. Well, 50 doesn't have a square root. If I took my calculator out, 50, hit the square root button, it wouldn't give me a whole number. So that means I need to use upside down division to figure out what this is simplified. I pick the smallest prime number that will go into 50. First off, I try 2. You know what? 2 will go into 50. 2 will go into 50 how many times? 25 times. Then I see if 2 will go into this again. No. The next prime number I check is 3. Will 3 go into 25? No. Will 5 go into 25? Yes. So I make this upside down division bar. I put 5 right there. 25 divided by 5 is 5. And as soon as I get a prime number, that's when I stop. I don't worry about these numbers up under the radical symbol. I come over here, I make another radical symbol. Some numbers are going to go on the outside and some numbers are going to go on the inside. How do I know what number goes on the outside? If I have a pair of them. I've got a pair of 5s. That means 5 goes on the outside of the radical symbol. Anything I have a single of goes on the inside of the radical symbol. The square root of 50 is simplified to 5 square root of 2. Let's try this process again with this next example. The square root of 180. I don't know. So what I'm going to do is I'm going to use upside down division to help me simplify this. And I only use prime numbers. 2, 3, 5, 7, 11, 13, so forth and so on. Will 2 go into 180? 180 divided by 2 is 90. Is 90 a prime number? No. So I keep going. I keep using 2 until I cannot use 2 anymore. 90 divided by 2. 45. Is 45 a prime number? No. But can I use 2 again to divide 45? No. I'm going to see if 3, because the next number I need to check is 3. It's good to go in order. You don't have to go in order, but it's really good to go in order. I'm going to use 2 until I can't use 2 anymore. 2 will not go into 45. So I want to try 3. 45 divided by 3. And 3 will go into 45. Always use the smallest one. 45 divided by 3 is 15. I keep using 3 until I can't use 3 anymore. 15 divided by 3 is 5, and I know to stop when I get a prime number. I come over here, make my radical symbol. I need numbers on the outside. How do I know what number goes on the outside? If I've got a pair of them. I've got a pair of 2s. So guess what? A 2 goes on the outside. I've also have a pair of 3s. Guess what? 3 goes on the outside. Anything I have a single number of goes on the inside. And what do I do with these numbers when I have more than one of them on the outside? I multiply them together. 3 times 2 is 6. The square root of 180 simplified is 6 square root of 5. How do I do that? I use upside down division. I use prime numbers and I find my pairs. My pairs allow me to write one on the outside. Anything I have a single of stays on the inside. We're going to simplify the square root of 360. So the first thing I need to do is check and see if 360 has a square root. 360, hit the square root button. Got a decimal, does not have a whole number as a square root. That tells me I need to use upside down division to simplify this. Always pick the smallest prime number. 2 will go into 360. 2 will go into 360 180 times. I continue to use 2 until I cannot use 2 anymore. Use 2 again. 2 will not go into 45, but 3 will go into 45, as we've seen. And I stop when I get a prime number. Next, I make a square root symbol. Some numbers are going to go on the outside and some are going to go on the inside. I have a pair of 2s right here. So that means I write a 2 on the outside. I've got a pair of 3s. That means I put a 3 on the outside. And what do I do with these numbers on the outside? I multiply them together. I have singles though. I have 2 singles. I have a 2 and a 5. That means I put a 2 up under here and a 5 up under here. Just like on the outside, these numbers get multiplied together as well. Multiply these numbers on the outside, I get 6. Multiply the numbers on the inside, I get 10. The square root of 360 simplified is 6 square root of 10. We need to simplify the square root of 51. 51, hit the square root button. It doesn't have a whole number as a square root. So what I need to do is I need to start dividing it by prime numbers. So I write 51, upside down division bar. 51 divided by 2. Doesn't work. I get a decimal. 51 divided by 3. 17. So 51 divided by 3 is 17. Is 17 a prime number? Is there more than one factor that will go into 17 besides 1 and 17? No. I make my radical symbol. This is as far as I can get. Do I have any pairs? I don't have any pairs. That means I can't write anything on the outside out here. Every time I have a single, I need to write it up under here. Just like on the outside, if I had 2 numbers out here, I would multiply them together. 2 numbers under here, I multiply them together. If I take 3 times 17, I'm right back at 51. So when I tried to simplify the square root of 51, it couldn't be simplified. It was already in lowest terms. Sort of like me saying this, simplify 2/5. I want you to put 2/5 in lowest terms. And most people would say, well, it's already in lowest terms. I can't reduce it anymore. Same with this. I went through this process. I saw there were no pairs, so I could not reduce this anymore. This could be another way you could see that it's already reduced. The fact that there's no pairs over here. Take my calculator out, see if 2 will go into it. It will not. I use 3, 5, 7. All of a sudden I figure out that, you know what, 11 will go into it. 121 divided by 11 is 11. Look, I've got pairs, but I also ended up with a prime number. These are my pairs. I write 11 on the outside of the square root symbol. Do I have anything? Do I have any singles? Because I don't worry about this. Do I have any singles? If I don't have anything up under the radical symbol, then I don't need the radical symbol. The square root of 121 is 11. Remember, you can take the square root of 121. It's 11. Don't go through this process and think that you always have to have a square root symbol. Some numbers actually have a square root, and you can simply just write down that number as the answer. That's simplifying it. So make sure that these don't confuse you. Make sure that you simply just write down, if I've got pairs, that one number. Singles go up under here. There isn't one. I don't need that radical symbol. The square root of 288. I don't know what the square root of 288 is, so I'm going to use upside down division. 288 divided by 2, 144. I keep dividing by 2 because I'm using prime numbers. 144 divided by 2 is 72. I continue to use 2 until I can't use 2 anymore. 72 divided by 2, 36. I take 36, divide it by 2. 18. I continue to divide by 2 until it doesn't work anymore. 2 will not go into 9, so I have to go to my next prime number, which is 3. And then once I get a prime number right here, I'm done making this upside down division bar. These numbers up under here, I don't need. I'll only look at these prime numbers that make up 288. I start pairing numbers up. There's a pair of 2s, there's another pair of 2s, and there's a pair of 3s. So I make my square root symbol. This means I write 1, 2 on the outside. That's where this 2 came from. There's another 2 I write on the outside. And remember, I multiply these numbers together. That's where this 2 came from. And then there's a pair of 3s. I'm going to write that 3 on the outside. So that 3 goes right there. So I've used these 2's, and these 3. Those numbers are written on the outside because I have pairs of them. Pairs allow you to write a number on the outside because of this index right here. Anything I have a single of goes up under there, up under the radical symbol. I need to multiply all these together. 3 times 2 is 6, times 2 is 12, square root of 2. Sometimes there is a number already on the outside of the radical symbol. So what we do is, we know we need to simplify this. We go ahead and put this 3 that's out there already. And then we start simplifying this part right here. 98, upside down division bar, 98 divided by 2, 49. 49 is not a prime number, so I'll find a prime number that will go into 49. 2 will no longer work, 3 will no longer work, 5 won't work, but 7 will. So again, I'm looking for pairs. This pair right here means I write a 7 on the outside, but I need to make sure I multiply it to whatever's already on the outside, that 3. Anything I have a single of goes up under the radical symbol. Things on the outside get multiplied together. If I had more than one up under here, it would be multiplied together as well. 21 square root of 2. So 3 square root of 98 is 21 square root of 2 simplified. This looks like there's just a negative symbol out here, but just like a problem like this, what number is in front of this x right here? There's a 1. What number is in front of that x now? That's a negative 1. So this negative symbol means there's a negative 1 on the outside of it. So I could do this. I could go the square root and go ahead and put a negative 1 out there. So it reminds me that there's a negative 1 out there. And now I'm going to simplify the square root of 72. I'm going to start with the smallest number that will go into 72. That's a prime number, 2. 72 divided by 2 is 36. 36 divided by 2, 18. 18 divided by 2 is 9. 2 won't go into 9, but 3 will. And I end up with a prime number. These numbers right here aren't important anymore. Every pair I can write 1 on the outside. I can write a 2 on the outside, times 2. I can write a 3 on the outside because I have a pair, times 3. Anything I have a single of goes up under here. Multiply all these numbers on the outside together. 3 times 2 is 6, times negative 1, negative 6, square root of 2. We're going to simplify negative 3 square root of 49. This negative 3 is out here on the outside. It's multiplied, since they're right beside each other, by whatever the square root of 49 is. And this is a situation where the square root of 49 comes out to be a whole number. The square root of 49 is 7. So this is really negative 3 times 7. So negative 3 times 7 is negative 21. Remember, if you can take the square root of a number, you simply write that down. And if these are beside each other, that shows multiplication. Multiply those together and you're going to get negative 21.